Hey folks, in this lecture, we will learn about the different types of neural networks used in deep learning. Each type is like a different tool. Some are good at looking at pictures, some are good at understanding voice or reading sentences, and some are good at general decision making. In this lecture, we'll focus on three of the most important and widely used types: feed forward neural networks, recurrent neural networks, and convolutional neural networks. Each of these has a specific structure and is used in real companies today to solve real world problems. Let's start with the feed forward neural network, which is the simplest type. This type of network has layers arranged one after another. Information moves in only one direction, from the input layer to the output layer, without looping back. This is why it's called feed forward. It works well for basic problems like classification, where we just want to put things into categories. For example, let's say we want to build a system that looks at customer data and decides if the person is likely to buy a product. The input could be age, location, past purchases, and so on. Each piece of information goes into the input layer, then passes through hidden layers where neurons process it, and finally reaches the output layer where a decision is made. One real example of a company using feed forward neural networks is Intuit, which builds financial software like TurboTax and QuickBooks. They use this type of neural network to classify users into different risk categories when analyzing tax returns or loan applications. For example, the network takes in a customer's financial behavior, such as payment history and income reports, and outputs whether that person is high risk, medium risk, or low risk. Since the task is just about classifying data based on patterns, and it doesn't require memory of past events, feed forward networks are a perfect fit.
Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Now let's learn about recurrent neural networks, or RNNs. This type of neural network is made for tasks where the current step depends on what happened before. It's different from feed forward networks because it has loops in it. These loops allow the network to remember information from earlier steps. You can think of RNNs like reading a sentence. Each word has meaning, but the full meaning depends on the words before it. For example, the sentence, "I saw a man with a telescope," could mean two things depending on how the words connect. RNNs are able to learn these connections. A real company that uses RNNs is Duolingo, the language learning app. When you speak a sentence in another language, the app checks if your pronunciation and grammar make sense. But it doesn't just listen to one word, it needs to understand the full sentence. Duolingo uses RNNs to keep track of what you said earlier so it can understand the context of what you are saying now. This is how the app gives you correct feedback and helps you learn better. The looping structure of RNNs helps the system remember your voice patterns, mistakes, and progress in learning over time. Another place where RNNs are useful is in typing suggestions. Let's take Grammarly as an example. When you start writing a sentence, Grammarly gives you suggestions to complete it. These suggestions are not random. They depend on what you've already typed. Grammarly uses RNN-based models to predict the next word based on previous words. If you type "I am going to," it might suggest school or the market because it understands sentence flow. That's the power of memory in RNNs. It looks at what came before and predicts what should come next. Now, let's move to the third type: convolutional neural networks, also known as CNNs. These networks are specially designed to work with images. CNNs don't just look at the whole image at once. They look at small parts of the image, find patterns like edges or corners, and then combine these patterns to understand what the picture is showing. CNNs are very powerful because they reduce the size of the image data while keeping the most important parts. That's why they work faster and better for images compared to other networks. A well known company that uses CNNs is Pinterest. On Pinterest, when you upload a picture of something, the app can find similar items or styles. For example, if you post a picture of a modern kitchen, it can show you similar kitchens or home design ideas. This is done using CNNs that look at the photo, break it into smaller sections, and find shapes and textures. Then the network compares this data to thousands of other images to find matches. All of this happens quickly and accurately thanks to the design of CNNs. Another big example is Tesla, the electric car company. Tesla uses CNNs in its self driving system. The cameras on the car capture images of roads, signs, people, and other cars. CNN processes these images in real time. It can detect where the road is, where a stop sign is, or if someone is crossing the street. CNN helps the car understand the world around it just by looking at it, similar to how our eyes and brain work together to make sense of what we see. Without CNNs, self driving would not be possible at the current level. So, this is a simple explanation of the three important types of neural networks: feed forward, recurrent, and convolutional. See you in the next lecture.